Okay, so this is the next question on the AIME 2022, and it says this essentially, right? So if you have 100A plus, and these are all distinct, yeah, C, B, and A, plus 10B plus C equals 81C plus 9B plus A, yeah? Okay, so you bring them all to one side, yeah? So it is kind of natural simplification, yeah? So you get A is 99A plus B equals ATC, or minus ATC equals 0. No? Well, 99A plus B equals ATC. Okay, so you don't quite have so just one equation with three variables, even if they're integers, you can't necessarily, well, you can get quite far into the solution, yeah. But um, but you also know that um, they're single digit numbers, you know. So you could even try to guess. So A and C should probably be close. Have you tried guessing some numbers? So I guess one good thing is we know that ADC has to end in a 0, right? And that means, so whatever A is, it determines what B is. You know? So like if 99A ended in like a 1, then B would have to be 9. You know? Um, hmm. So like I guess another way of saying that is, in like mod 10, that's the same as looking at the last digit. Yeah? Have you heard of that before? Okay. That's 9A plus B equals 0. Mod 10. So if A was 1, so if A was 0, B would be 0, yeah? If A was 1, B would be 1, yeah? If A was 2, oh, that's kind of crazy. If A was 2, wait, something seems wrong with this. I seem to be getting that 9A is minus A mod 10, and I'm getting that A is equal to B. Oh, did I do something wrong before? Wait, so A is not allowed to equal B.
It's not necessarily distinct.
What?
It's not necessarily
Oh, it said not necessarily distinct. I thought it said distinct, sorry. Oh, well, we proved actually then that A has to equal B, right? So, um, if the question said distinct, there'd be no solutions, right? Okay, so that's very convenient, yeah. So, so then we get basically AAC equals CAA, right? or another way of saying that is we get 100A equals 80C, right? Okay, so where do we go from here? So you don't necessarily need me to take it all the way, right? Like, but we just need that idea at the start, and then the rest is just kind of effort. Where do we go from here? Huh? Oh. I mean, at worst, it's a case batch with like a. Actually, it's not even 9 possibilities with C, right? Because it's base 8 by base 9, so it's only like 8 possibilities or 9 possibilities. So just go with the flow here. So your 100A equals 80C. What do you do next from there?
Divide by 20.
Yeah, I mean, cancel the stuff, right? It's like we differ by like at least 25 years, and we still do the same thing when we see that equation, right? So get 5A. The 20. Okay, the 20 thing is a little bit more than I was bargaining for. Equals 4C. Yeah. I was originally just gonna do by 10. Okay, but you even went further. You notice there was a 2 as well. So okay, so then you have 5A equals 4C. Yeah. Do you know what that means?
Substitute.
Yeah. Substitute into what? Okay, I also put 10A equals 8C. That's what I saw without the 2. It's just canceling out a 0, right?
So
89C. Wait, how do you get that? 89C.
100A plus 10B plus C equals the whole thing. And then because A and B are the same, it's just 110A.
Oh, that's what you're doing. Okay. 110 4C. Wait, are you talking about this side here? Or this side?
Yeah, the other side.
This side.
Yeah.
It's not quite 100. There's 110A plus C, right?
Yeah.
Which is like 1.25A. Yeah, sure. I mean, so you get 4x is equal to 445A. Okay, yeah, I mean that's fine. It's going for something a bit more basic though. Like, can you tell me something a bit more basic from this equation here? The one that you got. Something very, very basic.
and C have to be either 5 and 4, 10 and they have to be 5 and 4.
That's pretty good. Yeah, so yeah, I guess you can arrive at a few different ways. So if it's five times A is a multiple of 5, right? So C, things that are multiple of 5 have to end in a 5 or a 0, right? So 4 times C is obviously even, so it can't end in 5, it has to end in a 0. No? Hmm? So 5A has to end in a 5 or a 0, right?
Yeah, it can't end in 0.
Can't end in a 0. Why not?
Because it's a single digit.
Oh no, A could be like 2, right? A could be 4.
But if A's, oh,
Yeah. It actually has to end in a 0, right? Because it's 4C. So that tells you, okay, at least that A is even. So this is maybe a good opportunity. So this is a bit overkill for this question, but this technique is actually really helpful in lots of problems. So if you have like 5A equals 4C, right? So what this means is 5 divides 4C, right? Okay, so because 5 is prime, it can't divide, like it has to divide one or the other, okay? So 5 divides either 4 or 5 divides C, right?
so 5 has to be C.
Yeah, obviously it doesn't divide 4, right? So it has to divide C.
So C has to be
C has to be 5 or 0.
0.
I don't know. Oh, it was a starting digit, right? So it can't be 0 because it starts with a C, right? So C has to equal 5, right?
So A is,
So A has to be equal to 4, yeah. Um, but if we use the logic the other way, just to show this, I just want to give you an example. So if you have 4 divides 5A, yeah? Okay. So 4 is not prime, right? Yeah. So you can't use the same reasoning to say it divides out of 5 or 8. Yeah. But 4 is co-prime to 5. That makes sense? So 4 is co-prime to 5, then you can conclude from this that 4 divides A. Does that make sense?
yeah.
Yeah. So A can only be like um 4 or 8 then, right? Or 0. 4, 8 or 0, but it can't be 0 just as you said. And then C has to be 5. Yeah. But obviously if you combine them it's just 4 and 5. Hmm. So the answer seems to be, what's the answer?
5, 5. Oh wait, 4, 4, 5.
4, 4, 5, yeah? Okay, so this is one of those things you can check it much faster than you can solve it, right? So 4,
Yeah,
4,
I
5,
checked it.
you already checked it? Okay, so 4 times 9 squared plus 4 times 9 plus 5, and you already checked it.
Yeah.
36, 41.
No, it's 5. It's 5 times 9 squared.
Ah, the digits change, right? Oh, very good. 5, 5, 4.
It's
Yeah,
5.
5, 4, 4. So this B is a 4, yeah. Very good. So you get 40, and then you get 81 times 5, 405. Oh, okay, good. Any questions?